This portion of the lab project really is the culmination of learning about the one-shot instructions. Now, we're not going to use a bunch of one-shot instructions in this portion, but we're going to show you a really good practical application for a one-shot type instruction. So we're going back to the first conveyor application where we did the size detection, and we're going to use a one-shot instruction to clarify to the controller exactly what happened at the PhotoEye. This is where I think it gets really interesting, where you demonstrate what has to be true before the one shot and what has to be true at the time you got the one shot. It's not real complicated. It does take some discussion, so let's start looking at it. If you remember in an earlier lab project, M10, a practical example of seal-in logic, we gave you an application to execute that could detect rogue cartons. In this case, it was cartons that were larger than what was assigned to flow through this material handling system. You see two cartons there, a smaller one and a larger one. The smaller one can pass between those two optical paths of 1PE and 2PE without being detected simultaneously, meaning that that smaller carton, when it's traveling on one conveyor, will reach a point in travel where it clears the optical path of 1PE, but it has yet to enter the optical path of 2PE, which means 1 and 2PE will never be blocked at the same time. But the larger carton cannot squeeze through that space. It's going to break 1PE, then 2PE before it clears 1PE. This is the logic that we used, and if you remember, if 1PE and 2PE are blocked simultaneously, and the motor has to be running, because we don't want busy fingers going through the PhotoEyes and accidentally causing a size fault. So the motor had to be running when both 1 and 2PE were blocked. And then we sealed in that size fault. And now we're going to improve this concept using a one-shot so we can actually not only say both PhotoEyes are blocked at the same time and the motor's running, but that 1PE was blocked first, then 2PE. With this logic that you're looking at right now, you could, if there was a carton sitting in 1 or 2PE, you could just flash the other one, you got a size fault. Now, you can't make it totally idiot-proof, but you can add little improvements. So an improvement on this logic will be the logic we're going to do in this lab. Remember that we're using an earlier lab, probably M10. It would behoove you if you had the push button logic in there. Remember, we had logic to simulate normally open and normally closed push buttons for the start and the stop buttons. And then, of course, we had our buffer inputs, buffer outputs, and then our sequence had 4 primary rungs. The start system, conveyor 1, conveyor 2, and conveyor 3, enabled by the system. Then we added 2 new rungs for this project. The former code that I showed you was seal-in logic, and I said I prefer seal-in logic, and there is a way to do this with seal-in logic, but I want to show you a simple way so we can clarify the use of this particular instruction, this rising edge. And if you forget what it is, you can always go up to your instruction palette or menu, mouse over, pulse rising edge contact, one shot. It is a one shot. It's a combination of a true if on instruction and a rising edge one shot function. Save this and download. So right now the system is at rest. And of course you can't start a conveyor unless the system is enabled, which you can see in each rung. So the first thing we'll do is we will toggle the start system push button. Now remember that you have logic in the push buttons program that operates these push buttons, so to speak. It simulates a press and a release. We start up the system. Let's start up conveyor 1 by right-clicking, and you see now we have conveyor running. Now we'll go down to the bottom. What I'm trying to do here is I have the image from the manual down at the bottom of the screen. Let's bring that up just a little. This will help you visualize what's going on here. So this logic that we added, and this is the same functionality you had back in Lab Project M10, which you can see is what we're looking at. Okay, and in that logic used as seal-in, but you could still accidentally get a size fault with happy fingers going through the PhotoEyes. Let's say that there was a carton in front of 1PE and you went over and blocked 2PE accidentally with your elbow, or just being an idiot just for grins to entertain yourself, or one of your buddies walks by and wants to mess you up and runs his fingers through 2PE. Or the conveyor stopped with 2PE blocked and someone comes through and does the same thing with 1PE. This improvement on the logic here with this one shot requires that they be blocked in a specific order that would match the flow. 1PE then 2PE, not 2PE then 1PE, which the older logic would have given you a size fault. So let's go over here to our simulator and simulate a smaller carton down here at the bottom, the correct size carton going through. It's going to block PhotoEye 1 first, and then that's going to clear, and then it's going to block PhotoEye 2. So you can see 2PE went on, but you didn't get a size fault. And the conveyor is running, so it keeps on moving and clears the optical path of 2PE. Now let's say that something is blocking the optical path of 2PE. You know, there's a carton sitting there, and you can see in the rung that the text is red, which means that bit is on in memory. That means the PhotoEye is blocked. And by the way, I always assume in my code that I'm doing for training that the PhotoEyes put 24 volts DC on the input screw terminal when a presence is detected. There's light operate and dark operate, and with a lot of PhotoEyes you can open it up and you can switch it from light to dark operate. So basically what we're saying is if it goes dark, that means that there's an object there blocking the view. Now remember, there's other PhotoEyes that are reflective off of the object, and it's just the opposite. When it's dark, there's nothing there, and when there's light, there's something there. So you got to be careful what you're doing with your PhotoEyes. Okay, so we're just assuming if something blocks the optical path, that input goes on. It goes high. You get a 1. Okay, so PhotoEye 2PE is blocked right now, and it's been blocked for quite some time. It really doesn't matter as long as it's blocked for more than one scan, and 1PE didn't get blocked during that exact same scan, then this is what you're going to get. So let's turn on 1PE. You can see it's true, but you see you have no size fault. That's because the train left the station on 2PE within a fraction of a millisecond. So we avoid getting the fault. Now, if we continue to run that conveyor, it's going to clear 1PE and then clear 2PE. So now let's bring in a carton, block 1PE. It keeps traveling. It's too long. It's a row carton. It's the larger one down there. Then we block 2PE. And I see I have a watchdog fault. This may happen to you on occasion. When it does, you can go up to Diagnose, Fault, Clear Fault, and put it back into the run mode. And you're running again. There's several possible fixes. Lengthening the watchdog timeout period really isn't going to do it. It has to do with the number of processors you're running in your computer. Tech support says the computer's running too fast, so you have to reduce the number of CPUs that you're using. We're not going to go into that right now. We did that in another place in the manual. But it happened right in front of your eyes. It faulted. Okay, so we have something traveling through, and we got a size fault because even though it locked up, somehow I still managed to trigger input 3. We got a size fault. Rather than confuse the issue, I'll go back up here to stop conveyor 1, toggle that, and that resets. See, that resets our fault. Remember, this is conveyor 1. So what we want the operator to do when they get a size fault, once they clear it, so to speak, the cause, then they go push the stop push button. Well, the conveyor's already stopped. Well, actually it isn't in this case because we haven't added that into our logic yet. But eventually, when you get a size fault, it will stop the conveyor, and then we want them to use the stop button to clear the fault, and then they can start the conveyor back up. So you see it did work. Let's start our system. And by the way, the reason that this all turned off when we faulted the processor is because these type of instructions, the logic, CLN logic, drops out when you cycle the condition of the controller. So the simulator is behaving just like a real controller. This is actually a good thing to happen when I'm discussing this. So I got to toggle system enable back on. Then I got to toggle, I toggled motor conveyor 1. So we go down here and look at our logic, and you see we're all set. So let's run through a normal carton again. Block PhotoEye 1, clear PhotoEye 1, block PhotoEye 2, clear PhotoEye 2, no fault. Block PhotoEye 1, this time it's going to be a row carton. Block PhotoEye 2, and we latch in or set a size fault. Conveyor 1 is still running, so that's the next thing we're going to do in the lab is we're going to go up here and we're going to add an instruction that will stop the conveyor because we don't want the carton going on through. This is a row carton. So I'm going to leave it just like that. I'm going to go offline, make the change, and we'll do that together. And then we'll come back to see what the simulator looks like to see if it holds everything. So we'll save and we'll disconnect and we'll go to motor conveyor 1 logic right here. And then we're going to add a true if off, reverse coil, and I like to do it right from the field above it. Type in SI, you see size fault, output 0. Now the logic is done. Now we're going to have to download this. We could have done run mode change instead of going offline to make the edits. Back online with our edit. This was the only edit that we made. And notice that we dropped out motor conveyor 1. We're not going to worry about that. Let's scroll down. We need to start this back up, by the way. Remember, this says no size fault, right? True if off size fault or not size fault. We can't run conveyor 1 if there's a size fault. So we want the not size fault as a condition. So let's toggle conveyor 1 back on. And now we can go down to the bottom. And we have both PhotoEyes on. That's the way we left it. Okay, but the train has left the station. And we're kind of doing this in the middle of development. So this would not be a way to run the show here. In other words, so you're out there and the operator says, you know, I saw something that I'm not comfortable with, and that is this happened, that happened, and I got a size fault because I accidentally turned the carton at an angle and blocked both PhotoEyes, my handgun in there, whatever. So here you have a situation where they call maintenance, and maintenance comes and says, well, what can we do to remedy this situation? So they go in and they're going to edit the logic to look like this. What I'm saying is you're starting up with both PhotoEyes blocked. You're going to have to remove the carton, the operator would, and it doesn't matter which one they remove first, whether they remove it out of PhotoEye 1 or PhotoEye 2. So now we're back at rest. Okay, the conveyor's running, see, true, motor conveyor 1 is running. So we block PhotoEye 1, it clears, block PhotoEye 2, it clears, we're solid. Next carton comes along, row carton, block PhotoEye 1, and then it blocks PhotoEye 3. We immediately get a size fault. Now here's something else. If you adjust the spacing on your optical paths, you can't put them so close together that it just barely clears the leading and trailing edge of the carton. Because what if the carton's slightly skewed? In other words, what if it got bumped somehow? It's unlikely because with a gravity conveyor, one of the advantages of its approach to the leading edge of a motorized conveyor, if the motorized conveyor is not running, then one corner of the carton would get there first, but it would swing around and present itself square to the conveyor. But let's say that the conveyor is running and the carton comes down slightly skewed. Depending on the speed of the carton approaching and the speed of the belt, it could pick up one corner of the carton and pull it on skewed. So that's something you have to consider. So your spacing between 1 and 2 PE, you don't want to make it so tight that it just barely accepts the smaller carton. Okay, so we got a size fault. And the size fault could be that it was a skewed carton. The operator comes up and looks and says, oh, this is the right size carton, but he sees that it's skewed. How does he know it's skewed? Because the conveyor stopped the instant both PhotoEyes were blocked. But remember, in this lab, we're using a one-shot instruction for the second PhotoEye that has to be blocked. So what we're saying is that PhotoEye 1 has to be blocked first. Now, it is true that if they were blocked simultaneously, and I can't demonstrate that with a simulator. I don't even know if I could do it with push buttons or real PhotoEye. In other words, the carton would have to break the optical path of both PhotoEyes 1 and 2 during, well, before the IO scan, but before the logic is executed. See, that's almost impossible for you to simulate, but not impossible to happen. So it is always possible that scenario could happen. That's really splitting hairs here, folks. Okay, so we got a size fault. The operator comes along and clears it. It doesn't matter which PhotoEye clears first, 1 or 2. Let's go back up to conveyor 1 because it caused it to stop. Well, you can't start it because you still have a size fault, but it's set. Latch, unlatch is the instructions we're using. So what we did was we decided to use the stop push button as the reset. Why not? So you could add text that says stop reset conveyor 1. I'm just going to toggle it. It'll go off and back on. Remember, this is a normally closed push button. And now you see we're all set for another size fault. There were a few questions in the manual. There are 3 memory locations pointed to with variables. The variables are input 2, input 3, and motor conveyor 1. Are they all in the on state? Look closely before you answer. So if you're looking for what's on and what's off, what should you be looking at? Not up on the screen here, but in the manual. You're looking at the text, right? Input 2, input 3, and motor conveyor 1. They're red. Considering what you have learned about the set coil instruction, would the memory location pointed to by the variable output 0 be on if that rung were true, if that rung was true even for one program scan? Yes. Why is that memory location, output 0, not in the on state at this moment? Well, there's more than one possibility. First of all, is it possible for both PhotoEyes to be blocked when the motor conveyor is running and not cause a size fault? Absolutely. Because if you block PhotoEye 2, then you block PhotoEye 1, the train left the station on PhotoEye 2. That's a one-shot. So the rung's not going to be true. So it won't set the size fault. So that's one possibility. Going on with other questions, on the next page you had a list of blanks to fill in. And this was really a simple one. Basically, I'm just asking you to interpret what you see based on color of the different elements. Let's start with system enabled. It's red, therefore system enable is on. It's the direct contact is red, therefore it's true. Start conveyor 1 push button. The bit memory is off and the direct contact is false. Motor conveyor 1 is a direct contact. It's red, so it's true. And the text is red, so that bit is on in memory. Stop conveyor 1 push button. That text is red, so it's on in memory. It's a direct contact and it's true. Output 0 is blue, which means it's off. But it's a reverse contact, so it's true if off. Motor conveyor 1, the bit at the end there is on, and notice if it's on, it's on. So whether you're looking at the true if on instruction underneath start conveyor 1 push button, if that text is red, motor conveyor 1, it's going to be red everywhere in the whole program no matter where you look. If the bit's on, it's on. So motor conveyor 1 is on, and then the direct coil says that it's executing the true execution. Now the reason I elaborate on that a little bit is because if this were a one-shot type coil, it wouldn't necessarily be executing even though that bit is on. Because remember that with a one-shot, especially with a set, and that's not what we're looking at right here, we're looking at the direct coil. So that direct coil is executing, it's red and it's executing the true execution. This is all key to your understanding. You should play with this code continuously until you've exhausted whatever kind of scenarios you can think of to try to outsmart it. Okay, there was also a question looking at the previous screen capture, is rung number 5 true? No, it's not. But remember, that's a set instruction. Is output 0 on? Yes, because the text is red. Is the conveyor stopped? Well, it would be if that instruction was in there. So we're looking at rung number 5. You would have to go up and look at the conveyor rung to see if the conveyor stopped, but it should be stopped. Where is the conveyor stopped? Rung number 2. How would the operator clear the situation? Pulls out whatever the offending rogue carton was, hit the stop push button to reset it, and then hit the start button to get conveyor 1 going again. How would the operator clear the situation? Now that doesn't mean that that's what you're doing right here, because on the previous page you left it with a size fault, which means the conveyor stopped. It's just asking you how would you clear it. So the operator would have to pull the the rogue obstacles out of the optical paths, and then hit the stop button to reset, and then hit the start button to get the conveyor going again. Depends on what you did right here, what your answers are on the rest of this page. So let's assume that we left it like it was with a size fault, like you see on the screen. Try clearing the fault by toggling the stop push button. So I'm going to go up here and toggle the stop push button, and the fault is cleared. Okay, so you can clear the fault without doing anything else, but try restarting the conveyor. So we'll go here and we'll restart the conveyor. We cleared the fault, right? And the conveyor started running without removing the rogue carton. So the PhotoEyes are still blocked. This is a disadvantage to that one shot that the train left the station. So now we have a situation where both PhotoEyes are blocked, the conveyor is running, and the rogue carton is going on ahead. That means that we can't let the operator reset the fault unless the carton is cleared. So how would we do that? Well, let's save, disconnect, and we'll add that logic. So we want to work on our reset rung. Down at the bottom, stop conveyor 1 push button. If you press it, remember it's normally closed, so when you press it, it goes off and clears the fault. We don't want to clear the fault unless the PhotoEyes are clear. So let's add that logic. We added not 1PE and not 2PE into our logic. Both of those optical paths have to be clear when you push the stop push button for conveyor 1 to reset the size fault. Let's save this and download it. Let's make sure everything's running. System is enabled. We want to start conveyor 1. We have no size fault, so let's start conveyor 1. And we have the 2 PhotoEyes are still blocked, because remember, the operator calls and says, hey, I got a problem here. This thing will take off and run again without removing that rogue carton. You, the engineer, maintenance person, you look around and goes, oh, okay, I see what's going on here. This is a situation where, as far as you thought it through, the logic as it was previously worked, but not if you didn't follow the instructions of removing the carton and then restarting it. You weren't actually forcing them to remove it. You just said remove it and then hit the stop push button. It'll clear it and away you go. So if they didn't follow the instructions, they cleared it with the stop push button, cleared the fault, but they didn't clear the rogue carton, away it goes on down there and it jams up in the palletizer. So now we see if we were to have a fault, and I'm going to clear this because remember we're in the middle of an operation here, so I'm going to have to clear PhotoEye 1 and 2. Okay, the motor's still running, so now I can bring in a carton. PhotoEye 1, PhotoEye 2, we get a size fault, and it stops conveyor 1, motor conveyor 1. It would have been stopped before, but you tried to clear it without removing the carton. So that was kind of out of sequence. So now we're doing it in sequence. So now we want to try to clear by toggling stop conveyor 1. Now you can do this here or up in the conveyor rung. It doesn't make any difference. So that goes true and then false again, but it doesn't reset. Not unless you remove both. If I just remove one, then the rung's not going to go true. I have to clear both PhotoEye optical paths, then I can toggle the stop push button and it clears the fault. And now I can restart the conveyor and away we go again. Ready for the next carton. Okay, and in the book it said try clearing the fault by toggling the stop push button in your memory from your keyboard. The image shows the new code, therefore it would have to clear the fault if you had removed the carton. But in the image it shows input 2 and 3 are still on. 1PE and 2PE are still blocked. So the rung is false, and if you hit the stop push button it's not going to clear the fault. What has to be done to clear the fault with this additional logic? You have to remove the carton before you hit the stop push button. Okay folks, that's good enough for the one shot. Well, alrighty then. At this point you've got a pretty serious arsenal of instructions and concepts that you can use to start writing programs. Hopefully you are already on your own outside of this course. You've got a simulator or you got a real hardware controller. You should be dreaming up stuff to create, to operate for your own personal learning experience. That tidies up the one-shot instruction, and now we're going to move on to something else in the next lab project.